Section 4.3, parallel and perpendicular lines. We're still going to be doing the same thing that we did in sections 1 and 2 where we're writing equations of lines, but now we're kind of narrowing our scope and our focus here to specific types of lines or specific equations of lines. We're going to be focusing on two different types. The first type we're going to focus on are parallel lines. Parallel lines is a vocabulary term. Parallel lines are just two lines that will never intersect. So if you think about what parallel lines look like, think about train tracks. Okay, two lines that are never going to intersect. They're never going to cross. They're never going to meet anywhere. Okay, the reason they're not going to meet anywhere is what I've got written down here. The slopes are the same. That is why the two lines will never cross. So that is why the two lines are never going to meet. Okay, so like I said, the determining factor on whether two lines are parallel is the slope. So in the first couple of examples here, determine which lines are parallel. What we need to do is we need to find the slope. Okay, because if we have two lines that have the same slope, those are the two lines that are parallel. Okay, so let's find the slope of line A. Remember, slope is the letter M, and I'm just going to go left to right on all of these just because I don't have a whole lot of room to draw different arrows. So I'm going to just go left to right when I find the slope for all of these. So we start with our y values, 3 minus 2 over negative 4 minus 1. 3 minus 2 is 1. Negative 4 minus 1 is negative 5. So we could say that's negative 1/5. Let's find the slope of line B. Again, it's letter M. Okay, so then we'll have 0 minus 1 over negative 3 minus 1. 0 minus 1 is negative 1. Negative 3 minus 1 is negative 4. So clearly A and B are not going to be parallel. Okay, and now we need to look at line C. Okay, so for line C, again, slope is the letter M. We're going to go left to right, so we'll have negative 4 minus negative 5. The minus in the slope does not replace the negative on the number. And then we'll have negative 3 minus 2. So negative 4 minus negative 5 is positive 1. Negative 3 minus 2 is negative 5. So clearly you can see that A and B, or not A and B, A and C are the two parallel lines here in example number 1 because they have the same slope. Let's try another one. Number 2, line A, 0, 3, and 3, 4. So again, I'm going to go left to right when finding slope. So line A, that's letter M, equals, we're going to go 3 minus 4, and then we'll have 0 minus 3. 3 minus 4 is negative 1. 0 minus 3 is negative 3. So we have negative 1 over negative 3, or we could have positive 1 over positive 3. Negative over negative, same thing as positive over positive. For line B, again, the slope, let's see, so we'll have 1 minus 2, and we'll have 0 minus 3. 1 minus 2 is negative 1. 0 minus 3 is negative 3. Again, negative 1 over negative 3, same as 1 over 3. So we can see that A and B are parallel. Let's go ahead and check line C. Okay, so slope is M. So we'll have negative 2 minus 0. And then we'll have negative 2 minus 3. Negative 2 minus 0 is negative 2. Negative 2 minus 3 is negative 5. We can clearly see, we could rewrite this as positive 2 over positive 5. We can clearly see that that's not the same. So our two parallel lines here are A and B, okay, because they have the same slopes. Okay, and that's the biggest point with parallel lines. The slopes have to be the same. So when we're asked to write an equation of a line that is parallel to the given line and passes through the given point, what we need to know really is the slope. Okay, the slope of your original line here is 2. The only thing you need out of that original equation is 2. We don't need the plus 3. We don't need y equals. We don't even need the x. Okay, we just need the slope of 2. Okay, so if you think back to section 2 where I gave you a slope and I gave you a point, the only thing you needed to find then was the y-intercept. Okay, so again, we're going to use y equals mx plus b. We know the m, that's right here. X is going to be the 5, y will be the negative 4, and we'll just plug everything in. So we'll have negative 4 equals our slope of 2. Our x value is 5, and the only thing we don't know is b. Okay, the original equation that they gave you, the one that I've got crossed out here in purple, none of that is going to matter except for the slope. The only thing we need from that line or from that equation is the slope. Nothing else is going to matter. We're not going to have, I believe that was plus 3. We're not going to need that plus 3 in our answer. That has no effect on our final answer. Okay, so let's go ahead and finish writing or figuring out what the y-intercept is. So we got negative 4 equals 2 times 5 is 10 plus b, you need to subtract 10 from both sides. -4 minus 10 is -14, and that's equal to b. So now what we can do, we can write our final answer. We're going to have y equals our slope, we know that's 2. We still have an x in our answer, and then our new y-intercept, minus 14. This is your answer for example number 1. Notice there's no 3 in your answer there. There's not going to be a 3 in your answer. That 3 from the y-intercept in the original equation has no effect on your answer when you're told to do this task, where you're given the equation of a line and a point, and you got to write a new equation. The only thing you need out of that original equation is the slope. And once you figure that out, you can ignore the original equation. All right, let's try another one here. Y equals 1/4 x plus 1, and we're given the point -4, 2. So we're going to be parallel to 1/4 x plus 1, and we're going through the point -4, 2. So again, the only thing I need out of this equation is the 1/4. That's the slope. Okay, the plus 1, I don't need. I don't care about that. That's not what I'm looking for. I know that my slope has to be 1/4. Okay, here's my second point. Now I'm just going to do the same thing. I'm going to use slope-intercept form, y equals mx plus b. I'm going to plug in my m, that's 1/4. I'm going to plug in my x, that's -4. My y value is 2. The only thing I don't know is the y-intercept. Okay, so 1/4 of -4, so 2 equals 1/4 of -1/4, or 1/4 of -4 is -1. Plus b, and then we just need to solve for b. Going to undo this -1 by adding 1, so plus 1. 2 plus 1 obviously is 3, so my y-intercept is 3. So once I've got my y-intercept, this is what I need. I need the slope, I need the y-intercept. Write your final answer. Y equals our slope of 1/4 x, and then our y-intercept of 3. Okay, so that's a basic overview of parallel lines. Slopes are the same, they're never going to cross, and then we're just writing equations like we did in section 2. Perpendicular lines. Okay, I said there were 2. Second type is perpendicular lines. Perpendicular lines are lines that intersect at a 90-degree angle. So it's a specific type of intersection. So it's not like 2 lines that just cross like that. That's not parallel, or that's not perpendicular. Perpendicular means they cross, so that angle right there is 90 degrees. Now that drawing is not very good, but that with the little box there, that kind of says that that's supposed to be 90 degrees. The x and y axis. So if I just take out all those extra lines, the x and y axis, that's a 90-degree angle. That's perpendicular. Okay? What makes 2 lines perpendicular are the slopes are opposite reciprocals. So opposite meaning flip the sign. Flip sign. That's what opposite means. And then reciprocal means flip the fraction. Okay, so let me give you a couple of examples. So let's say our original slope is, well, let's just say 2/3. That'll be an easy one to start with. The opposite reciprocal of 2/3, so it was positive, so we're going to flip it to negative, and then we're going to flip the fraction over from 2/3 to 3/2. Those would be opposite reciprocals of each other, 2/3 and -3/2. Let me give you another one. Let's say your original slope was 4, or 4/1. Okay, and let's actually make it -4/1. Okay, so when we find the opposite reciprocal, find this, we need to flip the sign, so we're going to go from negative to positive, and then we're going to flip the fraction over from 4/1 to 1/4. Okay, so -4 has an opposite reciprocal of 1/4. Okay, and we'll do some more practice with parallel and perpendicular, specifically perpendicular here, coming up in the video. So the first set of examples here, determine which lines, if any, are parallel or perpendicular. Okay, so this one, they're not giving you points on a line, they're giving you the actual equation of a line. And this actually works in our favor because we don't need to do a whole lot of work. We just need to, if we put all of these equations in slope-intercept form, remember slope-intercept form, y equals mx plus b, once we get y by itself, then that number in front of x, that's our slope. So we don't actually need to actually calculate slope. We just need to rewrite our equations in slope-intercept form. And line A is already done for us. It's already in y equals mx plus b form. So we can say that our slope in line A is 4. Okay, so now let's do the same thing for line B, and I'll do line B in blue. So we've got x plus 4y equals 3. Okay, so we need to move the x across first, so we're going to subtract it. So we'll have 4y equals, so we'll have -x plus 3, but this is not slope-intercept form yet because we need to divide both sides by 4. We need y to be completely along. Okay, so the 4's cancel on the left. We'll have y equals, let's see, -x divided by 4. So if I have one pizza and then divide it 4 ways, each of us gets 1/4 of that pizza, but it was negative x, so it's going to be negative 1/4 x. The 3/4, we could write that, but remember, perpendicular and parallel are determined by the slope, and this 3/4 has nothing to do with the slope. That's the y-intercept. So do you need to calculate that? The answer there is no. Okay, the goal is to not write it in slope-intercept form correctly. We're trying to figure out the slope. So once we get the number in front of x, the rest of it really doesn't matter. Okay, you could write it, but it's not the biggest issue. So once we get this second equation for b, what is our slope? Well, our slope is negative 1/4. Okay, let's do the same thing for line C. I'll do line C in green. So we got negative 8y minus 2x equals 16. Okay, so we'll add 2x plus 2x, so negative 8y equals positive 2x positive 16. So positive 2x plus 16. Again, we need to get rid of the number in front of y, so we'll divide both sides by negative 8. Let's see. So we'll have y equals 2 over 8, simplifies down into 1 over 4, but it was positive over negative, so it's going to be a negative 1/4, and we'll have an x. We could do 16 divided by negative 8, that's negative 2. Again, you don't have to, not the end of the world. So here's our equation in slope-intercept form for line C. The slope here is also negative 1/4. Okay, so then the question becomes, which ones are parallel? Well, remember, parallel means they have the same slope. And let me switch colors. So I'll switch to orange. So parallel, I'll circle that in orange. Let me try to circle that a little better. So parallel, we're going to do in orange. Well, we can see that these two slopes are the same. And if the slopes are the same, then they are perpendicular. Or sorry, not perpendicular, parallel. That's my bad. Parallel. They're the same slope, so they are parallel. Perpendicular means opposite reciprocal. So the opposite reciprocal of negative 1/4, we'd switch the sign from negative to positive, and then we'd flip this fraction over from 1 over 4 to 4 over 1. And what we're actually noticing, or what I hope you notice, is that's what the slope of line A is, positive 4 over 1, or just positive 4. So perpendicular, we'll do that in brown. Perpendicular, well, we can see that line A is perpendicular to line B, and we can also say that line A is perpendicular to line C. Okay, so I know I got a lot of writing here. So parallel, let me go back to this. Parallel is going to be B and C are parallel, and that's the symbol for parallel, two vertical lines with a line underneath. And then perpendicular, well, we can say that A and B are perpendicular, and then we can say that A and C are perpendicular. Whoops. Let me get rid of that line there. Perpendicular. Okay, so we can say that B and C are parallel, and then A and B and A and C are perpendicular. I didn't leave myself enough room, so it's a little scrunched, but that's kind of what we're saying here. Let's try another one here. Number 2, y equals 2/3 x plus 3. Again, line A is already in slope-intercept form for us. Okay, so we can say that the slope is, well, we can say it's 2 over 3 because it's in slope-intercept form. Line B, let me switch colors here. We'll do that one in blue again. So we get 3x plus 2y equals 8. We got to get y by itself, so minus 3x. 2y equals negative 3x plus 8. Divide both sides by 2. So we got y equals, let's see, we'll do this. Negative 3 over 2 can't really be simplified, so we're going to leave it as negative 3 over 2x. And then we could do the 8 over 2 to get positive 4. So here is our equation. We can say that our slope is negative 3 over 2. Now, let's stop right there. Positive 2/3. Flip the sign to make it negative. Flip the fraction to make it negative 3/2. That's our slope of line B. So what we can say, without even going any further, is we can say that A and B are perpendicular. And I'll write that off to the side here. We can say that A and B, they are perpendicular. Okay, we'll make our first statement there. Line C, let's do that one. And I'll do that one in green. So we'll have 3y minus 2x equals negative 9. Get y by itself, so we'll add 2x plus 2x. 3y equals, we'll have positive 2x minus 9. Divide both sides by 3. The 3's cancel. So we're left with y equals, we'll do 2x over 3. So 2 over 3 can't be simplified. We'll leave it as 2/3. 9 over 3, that can be simplified. That would be 3 over 1. I need an x there on that 2/3. So then we got our equation in slope-intercept form. We can say that our slope here, the number in front of x, that is 2/3. Now, notice we said that a and b were perpendicular because the slopes are opposite and reciprocal. Flip the sign, flip the fraction. Okay, this is also 2/3, same as line A. So we've got a couple statements we can make. We can say that A and C, they have the same slope, so those are parallel. And then we can say something about B and C, because the slopes are opposites and reciprocals, we can say that they are also perpendicular. Hopefully I can fit it. There it goes. Okay, so we can say that A and B are perpendicular, A and C are parallel, and B and C are also perpendicular. All right, last couple of examples here. Write the equation of the line that is perpendicular to given line and passes through the given point. So very similar to when we were writing parallel lines, but now we're writing perpendicular lines. Again, in this given equation, this one right here, the only thing you need out of this is the slope of -3. We don't need the -1, we don't need the x, we don't need the y. The only thing we need is the slope. But that's the slope of the original line. So if it's going to be perpendicular, remember we need to flip the sign, and then we need to flip the fraction. So the sign goes from negative to positive. The fraction goes from 3/1 to 1/3. Once you get this information right here, a new slope, the slope that we're going to use to write our equation, you don't need this original slope either. Once we figure out what slope we're going to use for our new line, we don't need anything out of that original equation. None of that is going to be in our original or our final answer when we're done. Okay, so once we get our new slope, we can ignore that original equation. Okay, so we'll use our normal slope-intercept form process, y equals mx plus b. Let's plug in what we know. We know the y value is going to be 5. We know the slope is 1/3, where x value is -3, and then plus b. So we'll have 5 equals 1/3 times -3 is going to be -1, plus b. We'll add 1 to both sides. 5 plus 1 is 6, and that is equal to b. Now, the mistake I see a lot of people make, they'll go y equals, the original slope was 3, so they'll go 3x plus 6, and that is not correct. Okay? The slope that we used was 1/3, so this is the number that needs to be here right next to x. So I'm going to get rid of that 3x, and I'm going to make it 1/3 x. Once we figure out what our slope is going to be, that is the slope that's going to be in your final answer. Nothing from here. Once we figure out that it's perpendicular, once we get this sorted out, this whole slope, what it was, what it's going to be, once we get that figured out, none of this information is going to matter. The only thing that matters is the slope and the y-intercept, and that's what needs to be in your final answer. Okay? Let's try another one here. Number 2, y equals 1/2 x plus 3, and we're going through the point 3, 1. So the only thing that matters out of this is the 1/2, and it's going to be perpendicular. So we need to flip the sign from positive to negative, flip the fraction over from 1/2 to 2/1. And if it's over 1, really, we can just write the whole number. So our slope is going to be -2 in our new line. Once we figure that out, we don't need any of this at all. Okay, the original equation is no longer of use to us. We can just, this is now basically a section 2 problem. I give you the slope, I give you a point, let's find our y-intercept and write our equation. Okay, so we'll have y equals mx plus b. Plug in what we know. The y value is 1, the slope is -2, the x value is -3, and then we need to find b. Okay, so 1 equals -2 times -3 is +6, plus b. This is a single step equation, so -6 minus 6, 1 minus 6 is -5, that's equal to b. So we have enough information. We have our slope, we have our y-intercept. Let's write our equation. Y equals our slope of -2, x, and then our y-intercept of -5.